Hello everyone, my name is Cameron Mackenzie. I'm an applications engineer here at Man and Machine, and today we're going to be looking at creating parametric models inside of Fusion 360. So for this particular model, what we're wanting to do is create a tray that's going to sit on top of these two legs that I've designed inside of an assembly. And we want to make sure that when we are wanting to make any adjustments, any tweaks to the sizing of this, we've got some fairly basic parameters that we can adjust, which will make a difference to the overall component itself. So before we get going in there, I just want to make some measurements inside of this assembly. We've got the ability to come back into the assembly later on if we ever needed to, but I can just take some quick measurements of these components. So between the bolts, we've got a distance of about 80 millimeters. And from the first bolt in the front over here to the front of the component itself, we've got a direct distance of 33.45, but we do have a length of, let me see if I can find the right one here. We don't have a proper one on there. Let me just grab it from this face to that corner over there. We've got, if I remember correctly, this should be about 35 millimeters as well. So we've got 35 from the front of the component to the first bolt, and then 80 between those. So we can go in and create a new component as part of this design. I'm going to go and create this fairly simply. So in this new component that I've designed over here, I'm going to go and create a 2D sketch. I'm going to use the top or ground plane for this and create a center rectangle, which will allow me to choose the center point right at the origin, and then go for a width and a depth for this particular component. Now, when using parametric modeling inside of Fusion 360, we've got the ability to name our parameters as we start to place these in. So you can see at the moment, the first dimension it's asking me for input on is the width, and that's currently at about 300. I want to give it a value of about 400, but I also at the same time want to give it a name. When we name our parameters, we tell Fusion that these are important parameters and we want to make use of these particular parameters at a later point. So if I had to go in and say that this is going to be the width, if I could spell width, and say that this is going to be equal to 420. I can then hit tab to go and type in the depth that I want. I'm going to go and say this is the depth, and say that this is going to be equal to 250 for now. We can adjust this later on. As soon as I'm happy with those two, if I wanted to change either of them, I can just hit tab and switch between the two of them. But if I'm happy with that, I can hit enter, and it'll then go and create the sketch for me. As soon as I'm happy with that sketch, I can hit finish sketch, rotate my model around a little bit because I like to be in an isometric view. And then I can go and extrude this by a certain amount. Now the extrusion, I can also give it a name. I can tell Fusion that I want the thickness, or in this case, maybe I want to say THK. This can be any name that you want within certain reasons. There are some system names that you wouldn't be able to use. I think dia is one of them. So there are a few that you wouldn't be able to use, but we can get around these, and there will need to be a single word. They're not allowed to have any spaces in them, so you can either use camel casing or underscores to separate words. But I'm going to call this THK, and I'm going to say that the thickness is going to be, let's go for 2.5 millimeters. Hit enter, and we've got that set there. So that's all good and well. This is normal standard procedures really as part of this process, other than giving the names to our parameters. But where this does come in really handy is if we had to go into our modify panel. Right in the drop down we have change parameters. I've bookmarked mine or clipped it to the toolbar. So you're hitting the 3 dots over there. I can go and pin this to the toolbar. And so my change parameters button is right at the top in the toolbar itself for easier access. If I go and grab that, what you'll notice is all of the parameters that I have named, it has added a little star next to them and favorited them for me. So I've got a width, depth, and thickness. What this allows me to do is go and change those values at any point without needing to go into the sketch itself. So if I wanted to, I can go in and change the value of the width. Maybe I want to drop this to 350. I can hit enter and you can see the width of the panel changes. If I want to change the depth, I can go for 220, hit enter, and the depth changes, and same for the thickness. What Fusion have recently added is the ability to defer automatic updates. So if you were working with some more complicated geometry, in this case we've got a very simple model at the moment, but you can imagine if you were to make some big changes to certain values, they might start to break others without the other values being updated. We can defer updates temporarily, and I can go in and say, okay, this I want to go back to 400, this I want to go back to 250, and this I want to go back to 2.5. And as soon as I hit apply, it's going to go and apply these changes for me automatically and re-enable automatic updates. So it is just a temporary toggle that's available to me there. So really great functionality we've got while designing inside of this. And you can imagine the usage for this is when you've got a lot of components that might be very similar in shape and size, but you're just running various configurations of your particular component, or you are unsure of what those exact values are going to be initially and want the flexibility of making those adjustments inside of the design. What we also got the ability to do inside of this is then use those parameters and start to make some fairly complicated equations as part of this as well. So I'm going to go in and create a new sketch just on the top face over here. And I'm going to place down a single point for the location of a hole because I want to make my panel a little lighter so that it's not going to be too heavy for our stand. What I'm going to do is I'm going to go in and say that I want the positioning of this hole or this point over here to be 30 millimeters from the front and an equal distance from the side. Now I could go in and type that value in once more, but I can also go in and say I want to go and grab the value of the other component, the other dimension. And you can see it's automatically named that D5. If I had been better about this, I can actually go in and delete those two dimensions, add the dimension in once more, and give this a value. And we can say this is the hole position, or hole pos should be fine, and that's equal to 30. If I then do the same from the side to the point and place it down over there, I can say be the same, hole position 30. You can see how it's referencing that hole position as its value. Again, if I go into my modify dropdown and change parameters, which is also available inside of the sketch environment, you can see because I've given that a name, it's automatically favorited that for me. And again, I could go and change those values as and where I saw fit. If I hit finish sketch on there now, I'm happy with the positioning of that. I now want to go and place a hole in. So I'm going to use the sketch point to drive the positioning of the hole. So I'm going to use my hole tool, say that I want to use from a sketch, and I'm going to go and grab that hole over there. I can see I've got my hole created there. I've got an 8 mm diameter. Maybe I want to give this a name, so I'm going to say this is hole dia, and that's going to be equal to 8. So again, naming these dimensions as we put them in will allow us to then make use of them a little later on. So hit OK on there, and my hole diameter has been named, and I've got a single instance of that located there. Now, perhaps during this process, I want to go and create a pattern of said hole. So I want to go into my create panel, grab a pattern of that and say, you know what, I want to make a pattern of the feature. The feature is going to be the hole that I created, which I'm just going to grab from my timeline down at the bottom. And then I'm going to tell it that the axes that I want to go in are going to be the X and Y axes. I'm going to have a number over here. Maybe I want to say the quantity is going to be the, let's just see exactly which one it's using at this point. We've got one object selected. Why am I not seeing these there? Because the distance hasn't been set. Fine. So we've got a rough idea of what that's going to look like over there. And then I can say the quantity is going to be, double check that quickly. I think it's the X first in this particular case. Let me just double check that though. Yep, it is. Cool. So I'm going to say the X QTY is going to be equal to 4. And the Y QTY, or whichever name makes a bit more sense for you if you want the depth, so you can go the D QTY and W QTY, or whatever kind of makes sense for you. I'm going to go and set that to 3 in this case. Then because we are using a distance rather than a, or an extent rather than a spacing, we want to make sure that the distance of the overall pattern is going to start and end at more or less the same position in relation to the edges of our component. And to do that, we can actually start to make use of the dimensions that we've already added into Fusion. So we already know that the distance from left to right is going to be the width of the component. So we're going to say that the distance is going to be equal to the width. But we don't obviously want it to be the overall width because that's going to go over and extend that. So we want it to be, we want to subtract from the width. So we can put a minus sign in there. We want to minus twice the size of the hole offset. So I can go in width and in brackets, I'm going to say hole position. Whole pos, there we go, times, using an asterisk, I can find it on my keyboard, 2, and close the brackets. So we can use some fairly complex equations as part of this process, which is really going to allow us to hone in the positioning of our parts. And you can see now it's going to have the same distance from the one side to the other because the distance, half of the distance from the left is going to be the hole position. Then we've got the length minus twice the hole position. And we can essentially do the same process for the other direction. So if I go in, I'm just going to copy this to make it that much easier. And for distance 2, I'm going to say width value minus hole position, but I'm actually going to change this to the depth instead. And it's going to pick up the depth. And we can see that the positioning is exactly how we want it as part of that process. So I'll hit OK on there now and finish that off. So at the moment, it hasn't quite filled it in exactly the way we want it. But for now, that looks fairly okay. I can go into my change parameters once more though and start to fine tune that as and where I need to. So I know my width is 400. If I had to bump this up to 450, you can see the positioning of the holes in relation to the edges is still true because we set that value for ourselves. If I had to adjust that hole position value to 40, maybe I want slightly larger holes and don't want them as close to the edge, I can say 40. And that will then go and drive the hole positioning from the outside of the component in all directions because we've used that as part of the equation. We've got the ability at this point as well to change the hole diameter to 10 millimeters or more or less. And we've got the ability to change the number of holes in the X direction and the Y direction. Again, we can rename those if we wanted to. So we've got 4 along the width. So I can maybe say, actually, I want this W quantity and this to be D quantity. I can go and change that now. So if I wanted to double that, I can go for 6 holes in the depth and 4 holes in the width, and maybe bump that up as well to 8 and 6. And you can see how just by going in and changing a few values at this point, we've got the ability to really hone in again on the design of our component. If we understand the concept of it and we've got a design intent, we've got the ability of enforcing that then with the parameters that we come in and place. Now, as you see, we've got the ability to reference others. So if we wanted a certain width to depth ratio, we could adjust that as well. So we could say that the width is always going to drive the depth value as well. So the depth is always going to be the width times 0.8, or maybe let's go 0.6. So whatever value we give to the width, it's going to then adjust the depth as well. So if I had to change the width value to 600, the depth is also going to be changing at that point. So if I expand this out a bit, you can see how this works. We've got our parameter value, we've got the name of the parameter itself, we've got the unit of measurement that it's using, and then we've got an expression panel or column. And once it's made sense of the expression that we've created, it gives us an overall value at the end. So as I'm adjusting the one value, if I'm referencing any other parameter, say for example the width that is being referenced by depth will always change based on that as well. So it's a really great way of making sure that, again, we're keeping that design intent true as we go through. If we wanted a different value for thickness, we can come in and set that here. Hole position, hole diameter, number of holes in the width and depth. Rather than having to go in and try and readjust every single individual parameter every single time, we've got the ability to very quickly go through and adjust these here. Then lastly, we just want to go in and add those 2 holes. The 4 holes. Again, going to use a sketch for this one, just for the positioning of our components. And if I remember those values, I can always double check them, but I've got a point there, there, another one there, and there. And I'm going to add a dimension of, I think it was 35 millimeters from the front, and 80 mils from the first point to the second point. And then I want the holes on the opposite side to be horizontally in line with those two. So again, using our parameters, I can go in and change this value to 40, and it's going to drive the other values as well. If I change the 80 mil to 75, you can see the whole position for the 2 top ones changes as well. Fairly sure it was 80, and let's just make sure these are all vertically in line with each other as well. So I'm going to use my constraints to make sure they stay in the correct positioning. And then the last one is just a dimension from the side, which I didn't measure, but I'm going to just say this is going to be, I'm not going to name this one for now. I'm going to say this is going to be 15 millimeters just as a guide. And I want to make sure that these are exactly the same distance as that from the side. Finish sketch on this quickly. Create the holes that might be required as part of this process. So 1, 2, 3, and 4. And I want a diameter of 8 mil on these holes. And potentially I want to make them a little bit more complex. So I'm going to go and grab a counter bore for these. Let's go a little closer to the side over here. Maybe adjust the counter bore width or diameter. Bump this up to maybe a 12. The depth at 1 mil should be okay. And the other value should be okay as well. Rather than maybe a through all or a distance, let's go and say we want a 2 value. So it's always going to go to the back of our component as part of this process. Hit OK on that, and we've now got the counter bore holes created in a similar manner to how we had the other holes created. Once you're happy with this, we can save this file, and we're going to call this the laptop tray. Don't want to save it to camera case because that's the wrong location. So let's go into our Fusion overview and save it into that location. Great. So now that we've got our laptop tray created, we can go into our assembly and we can drop this item straight into our assembly. So I'm going to go into my data tray on the side here, go into the location that I'm wanting, which would be the Fusion overview, and we can see we've got our laptop tray available to us here. I'm just going to drag and drop it into my assembly. And okay, that I'm not going to worry about the positioning just yet. And I'll close my data panel just so I've got the visibility once more for this. From here, we want to go and add some joints in very quickly just to make sure that our components are aligned correctly. So I'm going to go and grab the hole over here and make sure that it's aligned to the hole on this particular component. And as soon as that's there, I can establish more or less if that is in the correct positioning, and my calculations seem to be okay so far. So we're all good on that. I can hit OK on that and place that in. Now we've got these other components over here which can't move around, which is interesting. I'm fairly sure they should be moving around. I haven't suppressed these. Let's suppress these very quickly, which should mean that they're not going to be causing anything. There we go. So we've got the positioning fine in relation to the tray and the stand. I want to go and do the same on the opposite side. So again, the bottom of that hole to the top of this hole over here. And okay that. And now we've got our two items somehow. Yep, the legs are attached. The bolts are just not attached at the moment. They can float around as and where they are. The reasoning for that is because they're associated to something else. So let me just go and remove and suppress those. So they should be able to move freely wherever they want. And very quickly, just go in and add some joints between the bolts and the holes that we've created over here. Might need to adjust those counter bores. They seem a little bit too small for the bolts that I've created. So that could be something I go and adjust. We've got the parameters for all of those now, although I don't think I did add it in for the bolts, but we'll ignore that for now. And last one very quickly, somewhere over here, we've got our hole and place it against there. So now we've got a fully assembled component minus the bolt on the nut on the other end, but we'll ignore that for now. Now we might notice in this one that the tray is potentially a little bit too long, so we might want to make that a little shorter. Might also see that perhaps it needs a bit of a rounded edge over there, so we might want to go in and make the adjustment to that. So if I had to go into the laptop tray very quickly once more, go and add some fillets to the edges, go and grab all 4 edges. Last one. And adjust the sizing of it. We had the 30mm on that item over there, so maybe about a 30mm should be okay on here as well, although we upped it to 40. But I'll go for a 30mm fillet on there and hit OK. Again, if we wanted to, we could name it at that point, but we can also go into our parameters. Into the list over here, we've got the model parameters that are available to us. And it'll list every single feature that exists inside of our component, including the hole 2 over here. And you can see the hole 2, we've got a hole depth, hole diameter, and then we've got our counterbore depth and counterbore diameter. I can go and call this CB dia as well if I wanted, and favorite it at the same time. And that'll now appear at the top of my list. And I've got the ability to go and grab the parameters inside of the fillet, which will be the radius, maybe fillet rad, and favorite it as well. It'll then appear at the top of my list. So now I've got all of the parameters that I ever need in there. So we've got that item, the radius of the counter bore that might be a little bit too small, and we can adjust that in the model itself in a few seconds. So if I hit OK on this now, we've got the fillet added in. Now that won't automatically update inside of our assembly, but as soon as we save this file, if I just hit a Control S and save the file and go back into my assembly, what you'll notice is it's going to be prompting me that there is a out-of-date model inside of my assembly and ask me if I want to update it. I'll say, sure, I want to update it. And it's going to go and one more time, update that file. Let's see. Interesting. Save it and update it. Interesting. Let's go and get latest directly from there. Odd. It's gone and gone. I've managed to get the latest version straight from the component itself. This might be something that they've changed recently that I'm not aware of. But we can see that we've now got the ability to go and grab that. We've still got, as I said, our bolt that's got a slightly larger diameter than the counter bore itself. And so the way we can go and fix that is actually by adjusting it. If we did want to, we've got the ability to adjust those exact same parameters inside of the assembly. So this is why it's really important and a really great functionality to be able to push these in the components themselves, is we can actually do an in-place edit of our individual components inside of an assembly. So as I hover over the individual component, I've got the little pencil mark available to me, and I can do an edit in place. If I do the edit in place, it's going to ask me to capture the current position, which is fine. I'm happy with the current positioning of everything. And you can see it's grayed out everything except for the component that I'm trying to adjust. So inside of this, I've got the ability to go and grab my parameters, and I get a grayed out version of the item, the rest of the components that are inside of my assembly. So I can eyeball and see exactly the size that I'm requiring for this. I could have measured that. I can still measure that if I want to inside here. And I can see that the radius is a 7 mil. So therefore I'm wanting a diameter of 14 or more. So I can go into my parameters, change that to perhaps a 15 or even a 16 might be a better size. And I know that I'm designing to the correct size for the assembly itself during this process. The other issue we did have is the back of our component, or the back of the tray, goes a bit too far for my liking, beyond the stand itself. Although it probably would be able to handle that, I probably want to just make sure it is a little shorter. So you can go and grab the depth value and say, let's go for 220 instead. And by adjusting that value, currently it's changed the positioning in the view, and that's just because of the location of the origin point. But as soon as I hit OK on here now and go and finish my edit in place, it'll automatically update that in line with the joints that we've applied. And we can see that the positioning is just a little bit better, and the sizing of that is so much better as well. Now, last adjustment will probably be this tray is way too small, way too thin. We probably want to go and adjust the thickness of the tray itself. So I can go in again, edit in place, change the parameters, change the thickness to a, let's go for a 3 mil or for 3.5 potentially. And maybe the tray itself is a little too wide at 500 mil. It seems a bit excessive. Maybe we can drop that down to 410. Again, it's not going to update the assembly because we're modeling in place, but as soon as I finish the in-place modeling, it's automatically going to adjust any constraints that might be adjusting the positioning or driving the positioning of the legs. And we can see that that's all automatically gone and set in the way that we want it to be. So that's just a quick overview of the parametric functionality, parametric capabilities inside of Fusion 360. You can see as we adjusted the one hole, so I didn't point this out, all of the others adjusted at the same time because they are all part of the same feature. So we've got the ability to drive that as well during that process. I hope this has been beneficial to you. If you do have any questions, any issues that you might have encountered during your testing of this functionality, please do feel free to get in contact with us. But other than that, thank you very much for your time today. Have a great day further. Goodbye.